Mike.
Oh, sorry. I couldn't place your voice there for a minute. I'm sorry.
That's okay.
My apologies. Takes a while to do.
It's like you're home, Michael.
Yeah. How are you?
Good. Are you home? I see the piano.
Home. What's home?
Yeah, that's what I thought.
What is home? Yeah, that's my wife's piano.
Yeah.
I don't play. She plays some.
Mm.
It's a beautiful instrument.
I'd love to have a piano. Is it an upright or a grand?
It is a Steinway A4, a 6.5-foot grand. Reconditioned,
Nice.
built in the teens or 20s of the last century, and then rebuilt by Faust Harrison Pianos here in New York. I'll play a chord.
God, what has happened to your face? Nice.
Yes.
So that's that. Who is with the ears?
Scott.
Just having a little bit of fun today.
Okay.
Does anyone know if it's possible to change your audio settings without rejoining?
Yes.
Where do I look for that?
Down on the lower left corner of your screen where there is a picture of a microphone, it says mute.
Yep.
There's a little tiny arrow. Click on the arrow and it gives you the options.
All right. Did that change my audio? Test.
Well, we hear you.
Well, we still hear you.
I'm trying to change my speakers. It didn't work though.
Well, it should work, because if you go down and it says select a speaker, you go to the mute button, you do the right, and then it says select a speaker, and it should give you a choice.
Yeah, I only have the laptop speakers and then same as system, which I plugged in a headphone jack, and everything else routes there.
Yeah, it would just, if you don't want the headphones, unplug the headphones.
No, I want it routed there.
Well, it should do.
All right, I might just sign out and join right back. I'll be back.
Okay. Hey, Aaron. I see chat.
Well, he just dropped out. He's probably going to come back in.
Probably. He's got something to show us.
Yeah, he said he couldn't unmute, but I'm able to mute and unmute without any issue.
All these complications. Hello, Thorin.
Hi, Thorin.
Hello.
Hello. Ooh, someone has a nice keyboard.
Yeah, that's me. That's me. I have a nice keyboard. Yeah.
Keyboard or typewriter?
A typewriter. I have both. So.
A nice mechanical keyboard. Yeah.
If you keep
I'm
tapping
the typewriter now.
If you keep tapping your keyboard that hard, you might not have it for long.
Oh, that's mechanical ones are loud. Don't have to hit them hard.
Yes, just answering. But the other keyboard is just louder.
Yeah, that's a bit louder.
Yeah.
You've got a piano too.
Schimmel. But it's not a grand piano, it's just a piano.
and upright. Yeah. Mhm.
Oh,
Aaron's back. He's still muted at the moment.
And Kevin is back with headphones working, so
good.
All
all's
right.
good to go.
Hooray.
Excellent. If you can hear me, but I'm able to mute and unmute.
I can hear you. Huh.
I wonder if that's a strange safety issue or something with Aaron having to do with you being recording the meeting.
I don't know.
Shouldn't be.
Shouldn't be, no.
Well, it's not for me either. Yeah.
I mean, it
Maybe
just shows it.
maybe you have to assent, there's that button to say okay and agree with the record to be recorded.
Right.
Oh, now we can mute and okay. I don't know, Aaron. No one else is having this issue. Yeah, I'm special. I don't know what to tell you. I wish I could help.
As far as I know, there's nothing in the host settings to prevent people from muting and unmuting.
Right.
Where did oh, there he is.
Oh, there we go. Can you hear me?
Yes.
Yay.
Okay, there was an OK button at the top that I guess I
Oh,
didn't hit.
that was it. That's the agreement to be recorded.
Okay, sorry, I missed that. I didn't.
I didn't see it at first either. It used to be used to come up in the center
Yeah.
of the screen, and
And
now
you can
it's
hear my. If I type though, I think the problem is I have like one of these mics, and if I type on the, it's like, it
That's
sounds
not
very
bad.
bass.
That's not
Yeah.
bad.
Okay.
bad.
Okay. It's very boomy and bassy in my ears, but I guess if it doesn't bother you guys, I can
So
always turn the mic down.
how many of you have been curious about this Coca-Cola app that seems to contain Csound?
I'm a bit curious about it.
I know nothing about it except what I've read in passing on the list.
It seems to be a new trend. I mean, didn't Audi or somebody did something like that as well? Well, Richard would know. He's coming in.
So I had a question about that. Like, I didn't want to ask on the mailing list and sound like an asshole or anything, but with Csound being GPL, shouldn't the source to that also be required to be available?
Csound is not GPL.
Oh.
Csound is LGPL.
Oh,
So
okay.
that
My
gives
bad.
anybody with the code the right to use it commercially as long as they propagate any of their own changes back into the public repository.
And I believe they used Cabbage to produce either a standalone or VST or something like that.
Okay.
And
That was my misunderstanding. I missed the L on the GPL with those
Yeah,
stipulations.
that was a discussion we had years ago when
yeah,
Okay.
GPL would be just too restrictive.
and
Yeah,
they originally
that-
made it GPL, and I said, wait a minute, no.
Yeah,
Right.
good.
That makes a lot of sense.
Yeah.
Okay. I'm glad I didn't ask that in that forum then. It
It's okay.
was a much better verbal answer than trying to sound like I'm stirring up a big can of worms.
Yeah, it
No,
sounds different in a
I
mailing
will
list.
say this, Kevin. I just joined for a second. Nah, that's not the sense of our forum. So even you asking that question or any question would help clarify it for many of us that are still confused. Even
That's
when
a
I
good
was
point.
trying to open source it with Michael's advice with Barry in the year 2000 and going to talk to the lawyers at MIT, I just thought GPL was the right thing. And then Michael said, wait a minute, there's all this. And so it's a complicated issue that we're
It
all
is.
still
It is
looking
complicated.
at. And so you should never feel like the forum isn't the right place for any question. That's the nicest thing about Csound. I keep trying to tell even my students, ask a question, make
That-
yourself known.
That's true, but at the same time, like I felt like I was asking for no reason other than to ask the question.
That's a
Like
good
I
enough
didn't have a
reason.
purpose.
That's
So
a good
like I
enough
felt a little
reason.
bit like a troll if I were to ask that. And that wasn't the
Oh,
purpose.
I don't think it would
Like,
be taken that
no.
way, but
right. No,
I
I
think
get it. And
Csound
I
is one
do
of the
appreciate
nicest
that.
mailing lists I've been on for years.
yeah.
Very,
I-
very
I-
friendly place.
Yeah, overall, I mostly agree with that statement. I think it's a very accepting community, but it was more me. I felt like I was the one being a troublemaker, so I was just like, it's not that important. I'm asking for my own knowledge, and
No, it's cool. It's cool.
all right.
Okay. So I have the feeling this is probably just about everybody is going to show up. So we have two presentations that are supposed to happen in this meeting. One is this waves business. And one is Aaron's microtonal thing.
Yeah, it's a score. It's a score translator front end that allows you to visualize. It doesn't have to be just for microtones, but that was the original use case. But it allows for you to use an ASCII text format to see things horizontally, like musicians are used to.
Right.
To find your voices, but you'll see. I'll explain it.
So do you want to just jump in and go ahead and explain it?
Sure, we can do it as long as that's okay with the other presenters. That mine won't take too long, and we can certainly cap the limit on it. But I don't know if you guys were itching to go first or not, depending on your schedule.
No.
Oh, Stefan just stepped out when I was going to ask him about what he's up to. And
I just switched the light on.
So
Yeah.
tell us a little bit about yourself and what you are hoping for from the meeting and stuff like that.
But me?
Yeah, you.
Yeah, okay. Well, I'm Cologne-based in Germany. I'm a piano teacher. I'm a composer as well. I'm playing in a tango band, making our own arrangements, and I'm very much interested since years in Csound. I think what I'm interested mostly is microtonality, so I'm looking forward to the presentation of Aaron.
Okay.
Great.
Fair enough. Are you, just in passing, are you aware of the tango piece that was realized with Csound?
Yes, I've realized some pieces with Csound. One or two I've posted to the list. At the beginning of this Corona period, I've made something like music concrete piece, which is a very simple idea. You will hear some spoken words, Corona, and words which were frequently used in that time. And these words are at the beginning quite unclear, and you can understand them more and more. If you would like to, and if we have the time, I could, of course, present you this piece, or maybe at a later time. So I think
let's do the 2 presentations I mentioned. I think there
Yeah,
will be enough time.
I would agree.
And then you can go after that.
Maybe,
I
yeah.
think there will be enough time.
Yeah, I think so too.
Okay, Aaron.
Great. Is my volume, my mic volume good for everyone?
Yeah, it's good for me.
Okay, good. I'm going to share screen.
Be sure to enable audio when you share screen.
Sure. Share sound, and I want to do stereo high fidelity. I'm going to go ahead and share. Okay, so you can all see my screen, correct?
Yep.
Okay, so first thing I'm going to do is go over to, let's see, will this allow me to move? There we go. Okay, so a little bit briefly about the background of this and my background. I'm a pianist and composer as well. I have a classical background, you know, when I'm not programming during the day for my day job in finance and doing Python and things like that for finance and some DevOps stuff. I still continue to learn. Right now I have a project to get through the entire Well-Tempered Clavier of Bach. I have book 2 pretty well under my fingers, and I'm going back. I know many of the preludes and fugues from book 1, but I'm getting those back in my fingers too. So I compose, and I have those kinds of especially early music, Baroque, pre-Baroque, especially have informed my compositional thinking through the years. And then I discovered through that doorway of equal, non-equal temperament through early music, I kind of, years ago, my mind was blasted wide open by discovering alternate tunings. And so it was like all about not only the past, but the future of musical tuning and kind of just getting us out of the, 12 is a great tuning and it's central to Western tradition. But I think there's so many avenues and exploration and sonorities that are available to composers doing other things as well. It's not either or, but both and. And so I founded on12.org. In fact, we have, coronavirus slowed us down a bit as a organization, but we're kind of ramping back up a little bit. In fact, we have a meeting in New Hampshire. I'm still on the fence about whether I actually will be there, but because I'm working on personal family scheduling things. But you can see the picture here. We're going to be in New Hampshire in June. So I encourage any of you who are interested in microtonality and able to make it to come and join that. You can join by contacting World Fellowship Center or reaching out to one of us. If you're interested, just contact me or Chris Bailey, who's on the board here. But the presentation today is about this tool that I have. And I first off want to thank Michael. Steven's not here, but Michael for making the WASM build of Csound available, because it's really heavily leaning on this web version, which I think I'm super excited about because it allows that zero install idea and people to just get in there and play with this. And it actually makes this tool, which I've spent some time over the years to build, I think much more exciting for people and much more easily available, because it's online and it's convenient for people. So thank you, Michael, for helping with that and guiding me on getting that installed and stuff throughout the list. So
you've got a couple of black bars overlaying your screen that are probably little windows on top of the window you're sharing.
Does
They're
that
probably Zoom
That
windows?
one
Yeah.
went
Yeah.
away.
Okay,
There's another
so
one on the right.
okay, let me see if I can get that one out of the way. It's not allowing me to move it out. I don't know if I can. Let me see. How's that? Is that better?
Oh yeah, that's
Better,
fine.
yeah.
Unobtrusive. Yeah.
Cool. What you're looking at now, assuming you can see, is the score. So I have an orchestra section, and I've kind of made a generalized orchestra here. The future of this app is going to go much further than this. So I'm just going to kind of give you essentially what I'm going to do is eventually build a authentication based thing where people can have their own orchestras and scores on the On12 site and allow people to kind of make it available on their own site. But I'm going to start with developing it on 12, and you can have an account and you can log in. And and you'll basically have URL shareable versions of this where once you've made an orchestra, and I'm going to change this to .msco instead of .mc, but the micro Csound score is basically a front end for your score. So I'm going to go ahead and render and show you what I mean by that. So I have an orchestra and I have this, and so the orchestra kind of gets copied wholesale. But all these I events are really just translations of all the stuff that you see here, which is more laid out horizontally with a horizontal mentality. So what you'll see here, for instance, the basic syntax is there's a few key values that are just set up as some letter and then equals and then something like this. So in this is obvious, like an instrument here, I'm defining instrument 1.1. When you see a string with little percent signs between it, these are for P8 and above. So like this would be P8, this would be P9, 10, and so forth. Now why P8? Why am I starting at P8? Because micro Csound reserves, obviously 1, 2, and 3 are reserved normally, like your instrument number, your start time, and your duration. P4 and 5, 6 and 7 are reserved for micro Csound because they use amplitude, attack, pitch, panning, and mix, and that in order 5, 4, 5, 6, 7. And so if you have extra parameters in your instrument, you feed them in a little sort of string array like this. The special values that I referred to before, like pan and mix, are just simple key value things that you declare with equal sign. And then you have instrument numbers, right? And so I'll dive in deep first, but why don't I just play you the example that gets rendered, and we can kind of hopefully I'll scroll as you hear it, and you can kind of get a sense how these are like staves. So essentially I have here 3 voices. This is a 3-voice kind of like late medieval, early Renaissance, late medieval piece by Johannes Ciconia. And then I added it's in chiptune, and then I also added 2 drum tracks layers. So this is sort of like a modernized, it's fun. It's a fun little arrangement that I did once for a Christmas album. So you'll see how this works, and I did render it in micro Csound, and as far as I know, I've been the sole user of micro Csound. I made it for myself, but hopefully it's a tool that others will find useful and exciting. And it definitely makes tuning a very quick, realizable thing, especially now that we'll have this web app. I'm going to use Edo 53, which is equal division of the octave 53. And so once you set this declaration up, the math just works out, and you can write your normal symbolic score. And I'll also show you that we have adjust intonation, pure like ratio based notation, as well as if you declare an Edo, you have integer based, you can declare your pitches as integers as well. There's 3 different notational styles available in micro Csound. So let's see if I can just render this audio, and let's see that you can all hear it. It won't be fun if you can't hear it, but the first time you do instantiate a web Csound, it takes a while to load, but then after that, it's almost instantaneous. So let's see if this gets going. Bring my mixer up. You all hear that?
Yeah, but now there's a window in front of the window again.
Okay, I'll get that out in a second. Okay, I'm gonna stop it and start over again just so we can follow the score. But how's the sound for you all? Not too loud? Pretty
Could
good?
be a little louder.
Okay. I'm gonna go back to that window then again. Here we go. I'll max out. Okay, that should be a healthy volume for you all. Let me just render it again. Here we go. There's the chant. Now we have Et in Terra Pax. We're here. demonstration of legato. The Amen. So there you
Okay.
have that.
Very nice.
Very, very cute. It's the weird chiptune thing and the medieval thing. The rhythms are very, what we think of as medieval. I don't know if anybody knows.
Yeah, it seemed
Yeah.
idiomatic to me.
Yeah. Well, that's the thing. It was like the adding of the drum part was fun for me because I could do these kind of like funky little cross rhythms and stuff. I find that that the medieval era has a lot of great rhythm to it too, and so it was sort of like this is definitely not authentic. First of all, it's already it's already electronic, but I'm also adding the drums, so it's not. I'm not going for authenticity here, except authenticity of spirit, if that makes sense, because I'm
I'm
like, I
sure
know
if
that.
you went to a fair in the year 1300, you would probably hear something like this with the drums and all.
Yeah.
I mean, it
Yeah,
sounds a little bit
you
like
might.
drum
Yeah,
horns or
I mean,
something,
there are early music groups that do add like non-obligato percussion stuff, and it can get quite funky, and I feel like it's still in the spirit. So this is obviously just taking that to a new level with electronics. Um, so just briefly, did it make sense to you when you were watching more or less what was happening in the music?
I
I
don't
didn't
quite
under,
understand how the rhythms work yet. I mean, the rhythms of the notes, if you
Hmm.
could explain that.
Yeah, so the duration, the running duration of pitches, the duration of each one is declared by a fraction. So this would be eighth note, and it remains the same until you say otherwise. For the same layer. So if I declare layer 5 here and layer 5 here, so these are like staves on normal scores. So it's going to be running eighth notes until it says otherwise. So here's a change where some like a little brief moment of 16th notes and then go back to eighth. The numbers that follow either a rest, there are two ways to write rests, R or Z, depending on what you want. Like Z is in snoozing. And then you can do so this would be a rest of 2, right? 2 beats of whatever the running time is. And then, for instance, this is a G, middle G, 4 pulses of middle G. Octaves are declared by a little, apostrophe. And if you want to go up 2 octaves, you would just put 2 apostrophes. So I can kind of, I can do something. Let's do this. I'll take out the piece here. So I can kind of give you, if I just do this, so I've declared everything that sort of sets up my structure. So let's say I want to do quarter notes, and then let's do C, and then C an octave below, and C an octave below that, and I'll render that. And you can go and see, now it's a shorter score. Let's play it. Right? And then obviously it can go higher. Let's do that. Okay. And if I want to declare a chord, so let's do, let's just do a C, E, G. This would be kind of Pythagorean because it's 53. And I'll show you how to do microtonal alterations. So let's see, a half note. Let's make it longer. We'll run. So there's a triad. Now, if I want to purify that, now it sounds more just because what I did was I took away the syntonic comma.
Huh.
So that, yeah, so there's different alterations of notes that you can have. Here, you all know about the 7/4 ratio, right? So if I wanted to go into just intonation, here's a just chord. I'll do basically it would be like a 4/6/7 sonority. So let's do that. Okay. But if I wanted to still stay in sort of normal notation, let's do that this way. So I'll have a B flat, but then I'll take it down a septimal comma, and we have that, right?
Very cool.
So
Yeah.
is this notation your own invention, or is this something like ABC?
This is actually Hume HEWM notation. M is for Monzo. I forget who the other people were,
Okay.
but on the tuning list on Yahoo before it folded, and different discussion groups, there are different competing microtonal notations out there. I find this one compelling because it still keeps the basic Pythagorean rubric, but then which is a 3-limit rubric because you're stacking your fifths, and your notation is based on that, and that's traditional. And then if you want to make nudges based on other overtones like 5, 7, 11, and 13, my system here goes 5, 7, 11, 13 are the main ones. As a composer, I usually stick to the 7 limit, but I can show you how it all works. Let's look at the. Let me go to where do I?
In my head, I've been comparing this a little bit to Lily Pond, and this is a lot more readable.
Yeah. Okay, I'm gonna show you the source code of this, and you'll see I'll go to the place where the notation is kind of parsed. Oh yeah, here we go. So this is JavaScript, so those of you who are not coders, but essentially, we're going up, we're defining our Edo, and then we have. I define everything's based on C, and then I have a tempered fifth, and the math, is like stacks of fifths and so forth. So here's going up a septimal comma, down a septimal comma, then the undecimal comma, which is the difference between, the 11th harmonic and then what you would have if you did, so for instance, if you're based in C, the 11th harmonic is essentially like a quarter tone from like F sharp, but flat. So you could raise an undecimal comma, you can flatten an undecimal comma. I don't remember my keyboard shortcuts for getting these upside down. This is like the Spanish upside down thing. So like, yeah, It's like the normal bang is undecimal comma, and then the Spanish bang, like when people say que, that's down, and then a tridecimal comma is the normal question mark, and then the upside down question mark is going down. It's been a while since I typed these, so I'm sorry to say I don't want to bore you by setting up my keyboard to do that, but I could cut and paste it to show you. But and then you can alter the mean, like if you're in a mean tone tuning like 31 Edo, you can even make the fifth, which is slightly flat, to accommodate the thirds. And if you don't know what that means, I'll take you aside sometime and talk about that. But because I don't want to do too deep a dive into how the tuning works, but you can actually nudge nudge your fifth up by a mean tone comma to make it pure again. So the nice thing is, you have this ability to, you can actually type these things here and zone out to the beauty of just intonation sonorities like very, very easily, and you can test different ones, right? So here's some obvious ones. And let's make this, I'll pan it to the center by changing that. I'm on the one line here. So you can hear it towards the right, but let's put it back in the center. Right? Now check this out. You can have fun with different sizes of thirds. So let's try, this would be called a septimal minor third. And then we have the normal 5-limit minor third. And let's go for, let's try a neutral third of 11/9, followed by the normal major third. And let's go super major. That's the interval between a perfect fourth. I'll write a perfect fourth on the end here. And let's throw something in here for fun. Let's do a 14/11 major third. So these are starting to be super major. And let's hear the quality of those minor thirds. So it's all available right here. You don't have to tune your instrument. You don't have to define a tuning table. It does the math for you, and if you're interested in just rapidly exploring these sonorities, here you go, right? So that's the kind of dream that I've had. It's like, I don't want to have to retune my fucking instrument. I just want to go and see what these things sound like. If you want to define an Edo, a strange Edo, let's try 7. This is the diatonic scale of major and minor squashed into a space where there's no large steps and small steps. They're equal sized. So let's hear them as dyads. Well, I'll do this. I'll do it as a simple scale first, and I'll do it as a and I'll tie the end one. There you go, and let's make it a little faster. By the way, you don't have to limit yourself to quarter notes or half notes. You can do third notes. So you can do all sorts of polyrhythms too. Okay.
And it looks like by repeating a note, it gets extended, gets sustained.
So if I put TT, that means tie, 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 right? So in other words, the last event gets held.
Got it.
In this notation, right? If I were going to do it as if I were going to do it like in the normal notation, I would just do a dash, or twice as long plus hold to the next value. That would just be a dash like that. So there's, like I said, there's different types of notations. I introduced you to the JI kind of notation where you use the colons to represent ratios. And then here's the integer-based notation when sort of like your letter-based thinking goes out the window with a weird tuning. You could just say, okay, just give me the number where what we would tune as C is 0 always. And then, and this can go, you can even do this. Middle C would be 5.0 octave. So if I wanted to go an octave, if I do this, all of a sudden I put the 6 in front of it, and then I jump back down to 5. Here's how that works. So you hear I jumped in this kind of integer notation. Well, it's actually floating point one. So it's sort of integer if you don't add the octave, but then it becomes floating point. And if you do it floating point, it's octave and then degree, if that makes sense.
Yep.
And then let's see. Oh yeah, let's do. Now I can show you dyads. So I know it's boring. We're sticking on C, but here's a dyad. Your dyad, 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 dyad. And then if I want to hold these, I do it within the dyad. And let's check that out. Okay. The sky's the limit with this. You could do, any kinds of chords or, anything you dream of like that. So for tuning like 17, which is interesting, you get these neutral triads. So if I did, there's 10 degrees of 17 is a perfect fifth. Let me show you that. And it just so happens you get this neat sonority with a neutral triad. I'll tie those out. So, you know, that's how that all works. And I wanted to show you, I have a pluck, I have a little fun piece that uses a lot of JI sonorities via, I'll show you one more little piece. It's not too long. Let's see some files. Let's see, cat. Okay, so let me just cut and paste this puppy here into the window. I'm going to copy. I'm going to select and I'm going to paste. Okay, so this is a piece. How many of you have taken piano lessons and remember the old John Thompson Teaching Little Fingers to Play series?
Yeah.
So the joke here is teaching little JI robot fingers to play. And I'm using a kind of a pluck, you know, simple pluck instrument here. So I'm using the same orchestra that I had here, but you didn't hear the pluck instrument two. It's very simple. Here we go. I'm gonna translate that. So you got all the, you know, you got your score gets rendered from the micro score, and then all your events are here. Let's see what this is. Lots of comments there. Back to the page. And that's it.
That's
So I
really
have a
cool.
question. That was really cool, but that made me want to hear, is there a way for this notation to represent pitch bends?
Oh, good question.
You mean so you
Not
can
the,
control a MIDI instrument
yeah, I
and
mean
get
that
the,
would be
Well,
the,
not so much a MIDI instrument, but say
but
if
an
you know
event,
you
right? Like,
want,
yeah,
right,
yeah,
you know you want a note to bend from just
yeah,
intonation to
yeah.
whatever, or
Yeah,
something like that.
good,
You
Right.
could do that
good
in the
question.
instrument design. I don't know if you could do it in the score.
You could probably
You could have an extra
represent
key
a
field
signal
that
of
would,
some sort, you know,
yeah,
an envelope of some sort, and trigger that with one of these events or something.
yeah,
The other way to do it would be to have a very rapid rhythm and really define,
Ah,
like
yeah,
be in a really fine-grained Edo and just, you know, you know, kind of bend
yeah,
up by just
okay.
like, you know, like
a
64th notes
granular
or
bend.
something, you know. um, that would be the way I would implement it now. But I thought about this problem, and I don't yet have an implementation for it. But that is a valid question and a good future for this, for sure.
Okay.
Does anyone else
Um,
have any questions about this?
Unrelated to that, I had one more question. When you were talking about the parsing, I don't remember if you said it was Java or JavaScript.
It's JavaScript, and
Okay.
yeah, so the original app, Micro Csound, was in Python, and
Hmm.
once I started thinking about getting this online, of course, JavaScript is in every browser, and the code. If you go to this page, I'll send the link to you guys. If you view page source, can you see my screen?
Yeah.
yep.
Okay, so I can walk you through very, very high level. You know, I don't want to take time from the other presenters, and I'm mindful of that. But um, you know, there's a header here. This is the magic. Thank you, Michael, again for loading. You know, I basically have a copy of the stuff that came in Michael's WASM package, and so much of this is pretty much unaltered from his. And then, you know, I have a demo here. Eventually, this, like I said, this will be a dynamic page where people can basically get an MD5 hash of their piece and their, you know, their orchestra and score, and it'll be a URL that's shareable. And if you log in, you can save that and edit it, and it'll always be like non-destructive.
That's what they do in Strudel.
Yeah, yeah.
So the
And
reason I asked about Java versus JavaScript is in the back of my mind. It's been a while since I've used it or been active, but Stephen Yee's Blue, I thought it
It's
might be
Java.
really interesting to have this incorporated as a type of score object where you could maybe choose to have score objects you work with within Blue that notate in this format rather than traditional
I
CSAP.
think at one point, Steven had mentioned to me, you know, micro Csound could be a plugin in Blue, and that I'd be totally
Right.
down with doing that. I don't use Blue myself, but I think I would be excited to help him implement
I
that.
think that could be really interesting for someone
Yeah.
who's into microtonal work.
Yeah,
Yeah,
and I
because
think
Blue
like
is a great tool and they would be
yeah,
very powerful together.
yeah, and then like for instance, these um, I find this notation very fast and like, you know, even faster in some ways than a piano roll, which I know Blue has. I mean, the piano roll is great. You can drag and drop events, but somehow I find that typing in sometimes is faster. But it would be that like you could actually, in theory, render a micro C sound score, hit some kind of render button, then it would also be a piano roll, so there'd be two different representations of the same events, you know.
Yeah.
Um, but essentially, yeah, you saw this part where there's a solfege to ET function. You can kind of peruse the math of this and how that works, but essentially I'm using a chain of fifths idea for the normal notation. And basically the entry process is this parser, like it just kind of tokenizes the strings that you come in, and it just basically tries to figure out what type of event is being asked for using regular expressions. And then each regular expression event that gets recognized has a handler function that handles it. And by handling it, it basically assembles and concatenates a large string that represents the C sound score with all the I events. You know, so it's you know, you could. I'm happy to, you know, I don't want to deep dive into this too much. I'm happy to answer questions, but you can, you know, the code is available to you if you just go to the page
That's
and then
right.
hit, you know, view source code.
Aaron,
Yes,
have you heard of John Baez?
Joan Baez, but not
No,
John
no,
Baez.
John Baez, who happens to be the cousin of Joan Baez. He's a mathematical physicist. He has a deep and well-informed interest in tuning systems. I pasted a link to his diary
Mm-hmm.
in the chat.
Mm-hmm.
And he has other things to say about music theory and other places on his website that
Right.
you might
Yeah.
want to check it out.
Excellent. I will check it out. And I'm assuming you guys want the link to this, so let me. I'll yield the floor in a second. As long as no one else has any more questions, I could.
I've got a question for you, Aaron.
Yes.
How do you find the time to do this?
That's a great question.
You know, it took a while. My programming foo has gotten a lot better through the years, so I can rapidly prototype some. Like it actually took me less than a day to take this and turn it from Python into this. Partly because I leaned on the help of ChatGPT. I
Yeah.
basically said, here's some Python code that's doing this thing. I want to make it a web page right quick. And ChatGPT is great, but it's not perfect. So, you know, I had to tweak a couple things and find mistakes in it, but it largely, you know, got me 80% or more of the way there. But yeah, and to answer your question, I did take a while to do this and assemble this. It was more of a burning need on my part. Like, sometimes when you commit to wanting to have a tool and it's not out there in the way you want it, you build it yourself. And if you're passionate enough about it as I am, you just do it, and it takes as long as it takes. But this tool has allowed me to render and write some of the pieces that out of all my output, I think some of my most successful things have been built with micro Csound. And of course, Csound itself is a huge part of that. Like, I wouldn't be able to, micro Csound wouldn't exist without Csound. The beauty of it is the score system of Csound. I think that's one of the things that I think is the secret weapon of Csound. So many other tools that are great and powerful are all with the MIDI paradigm, and they're stuck in the MIDI paradigm. And with microtones, it's particularly frustrating because everything that you want to do is all about pitch bend. You could do an OSC type system, but then the software that's receiving it has to understand OSC. And look, MIDI has the advantage of all the timing and triggers and sequencers and stuff, but then you have to hack it. If you're a microtonalist, you have to hack it with pitch bends. And the earlier version of this micro Csound was called Micro Composer, and that's precisely what it did. It output a MIDI file with bends. But you're limited to one channel, and the channel has to be like, you can't do things like release times that are hanging on forever and things like that without getting weird. The next bend that comes in, there's all sorts of artifacts that get in the way. So Csound is actually made for this, I think. To do microtones. It's the ideal tool for me.
Yeah.
Plus, you can define. You could do it. You could still use MIDI, right? But you could define tuning tables and all that stuff. There's so many ways in to microtonality with Csound. But this tool allowed me to think like a musician in terms of a score, and defining a score in ASCII horizontally without having to get into, worrying about lining up. I know that there are some people that used to, and I think it's kind of mind blowing that they were able to do this. Was it Bill Alves? You ever hear of Bill Alves?
Yeah.
He used to write microtonal scores raw.
Bill is great.
With he would just write the score.
Wow.
And see, I could do that if but I just don't. That would be, to back to your question, Thorne. Like, how do you have time to? I would ask him, because like this, I said once I build this, then it becomes easier for me. That I don't understand. Like writing a score like that raw. I think I understand why Csound was set up that way, with the flexibility of like, it's just definitely a slightly human friendly, but mostly very machine precise way of writing things. But
this is what's so powerful about Blue, is that it uses the same capability,
yeah,
at least great visual things that translate down to score events.
Yeah, and that's the I'd love to see this turn into something that became a plugin in all these other tools. But I just sort of maybe I'll talk to Steven about that and see if he knows. I mean, now that he sees the score, he's a genius coder. I'm sure he would come up with a way of making it pluggable in Blue within a couple hours or something.
Well, it might be possible, for example, to integrate a JavaScript engine that runs in the Java VM, and then it wouldn't even have to translate the code necessarily.
Right.
It's been a long time, but I feel like it's already there.
Yeah, it might be.
Yeah.
Okay, I think maybe we should move on.
Yeah, we should move on. But thank you all for your rapt attention.
Thank you. I think this was very interesting. And
Yeah, thanks.
Aaron.
That was
Thank
fascinating.
you. Fantastic
Thank
stuff.
you.
future iterations.
Yeah. I'll let you guys know on the list of any future iterations. I will be right back. I'm interested in this next thing, but I do have to grab some water, so I'll be right back. But go ahead without me.
Okay.
All right.
Thanks, Aaron.
Thank you. Thank you.
Thank you.
All right. Hi, Drew.
Drew is back in the trees there somewhere.
Maybe he stepped away from his screen.
Yeah.
Okay, so Scott, Jeanette, do you want to get going?
Yes, we would. Okay, for the presentation we have next, Scott will share video and audio. And yes, Scott and I, we would like to introduce the OND being French for waves, and it's a wavetable synthesizer, synthesis toolkit, or wavetable creation system. It's still definitely a work in progress, so definitely pre-release. More about that in a while. To understand what it is, I guess we should start at the beginning, at its inception and motivation, and that is definitely where Scott comes in. Your floor.
Okay, can you hear me okay?
Yep.
I can hear
Yep.
you.
I'm gonna I'm gonna need to read off my notes here, so you'll excuse me if I don't pull up my live video so you're not all staring at me reading. So let me just shrink this down. My initial interest in Csound, because I'm largely using the Android platform, was that despite that there's quite a few good DAWs available, there was a large lack of granular and wavetable synthesis options. So that's sort of what initially led me into Csound. And quickly touch on some of the advantages that I found of using wavetables. So you can get a large amount of timbral flexibility with using very few resources. So as the tables can be pre-calculated, it doesn't require using as many oscillators simultaneously and finding a way to interpolate between them, etc. And of course, there's the issue of availability. So with a lot of the plugins available like Serum and Vital and the hardware options, there's a huge selection of wavetables available on the internet. And of course, they allow quite a degree of controlled randomness without using as many resources. So I initially started a while ago. I was using a system that would import single cycle waveforms, like a full directory, using the tab morph opcodes, but they're pretty cumbersome because you have to write huge tables and they have to have the exact amount of wave like parameters to allow the waveforms. And it wasn't very flexible. And as I was sort of researching this stuff, I came across one of the manual examples for FT morph. If you look at the canonical manual FT morph example, they use a table with a gen table with a partial of single partial with a strength of 1, and then you have a 0, 1, so it's just the second partial, and then 0, 0, 1, just the third partial, etc. And it does the FT morph through it. And of course, being big into algorithmic stuff, my first concept was like, what would happen if I just created sort of a recursive Udo that would automatically fill, like just randomly choose partial strengths and create a wavetable via a bunch of single cycle waveforms. And it just slowly evolved from there. So at the moment, that sort of evolved into using 4 basic methods to create the waveforms. The first would be spectral, which is just in harmonic and inharmonic partials. And some people may or may not recall, a while back I posted a piece that was and some code for something that was called cinematographic strings, which was waveforms that were use sort of a half pulse, half saw, etc., which I'll get into in a minute. Then there are wavetables which are generated through a process of noise, for lack of a better term, creating points within waveforms. And there's several methods of doing that. Some of them involve Gen 16, so you can randomly create a whole bunch of tables of different sizes, 4 points, 8 points, 16 points, whatever you want. And the points are connected or interpolated via slopes, similar to like a transect envelopes. And you can have fixed slopes, you can have random slopes. It's quite complex. Again, I won't deep dive into that because it's just, we just won't have time to really do that. The fourth method involves importing wavetables or creating tables from longer audio files. So for example, this would allow you to import directories of tables that you get from the internet. For example, AKWF. There's quite a few waveforms and they're all single cycle. But then you get a lot of wavetables that consist of single cycle waves, but laid linearly along a single wave file, which is where programs like WaveEdit come in. And there's literally hundreds and hundreds of wavetables that people have created from hardware synths and converting serum, vital wavetables, etc. So I think the spectral harmonic partial kind of concept is fairly straightforward. So I'll do a quick screen share and explain a little bit about the concept of some of the geometric shapes here.
Maybe I could quickly cut in while you start the screen share.
Sure.
So in the basic operations of the wavetable synthesizer, we identified 3 main parts that are important to such a system, especially if you want to use it as a synth voice. And Beyond can do more than that, but basically there's the generators, which is just what Scott is talking about. Then there is the morphers or scanning opcodes, so how to go through a wavetable. And finally, there's the oscillators, i.e. playback opcodes. And of course, Csound already offers some, like P-oscil, oscil, the table opcodes, and many more. But yeah, of course, the main focus there, or the main magic there, does happen within the wavetables. And yeah, Scott, I think you have your graphics now, I suppose.
Yep. Can everybody see that okay?
Yes.
Okay. So upper left, you can see essentially a wavetable that's shape or a geometric shape that is like a trapezoid. So we have 0 going up to 1, across to 1, down to 0, down -1, -1, back to 0. Now, using that as a basis for a wavetable, if you look to the right, you'll see that that what we can do is create a wave that goes straight up to 1 and then a very, very brief amount of samples. It could be 1, it could be 10, whatever. And then it diagonally rotates. You'll notice there's a little circle in the middle of most of these, which sort of indicates your 0 crossing point. So we're looking at creating symmetrical wave shapes here. And by doing so, we can start with a saw. So as you algorithmically generate the table, you can extend that little wee section of, say, 10 samples at the beginning and move it over to the middle, and we now end up with a triangle wave. And if we continue sliding that over, we end up with another saw wave, but it's out of phase with the original saw wave. One of the beauties of this is that you can create them linearly in the wavetable. So as you morph, you're getting a very smooth sound. It's going from saw to triangle to saw, etc. But then you can shuffle the table. So there's sort of advanced options available. And when you shuffle it, you're sort of randomly jumping around, which will sort of tie into the next two diagrams down, sort of number 5 and 6. You can see it starts with a square wave. And of course, if we extend the upper section of the square wave and slide it all the way to the right, we now have a pulse wave. So again, if you create this and choose to do it in a linear fashion, when you morph through it, it's going to go very smoothly from the square up to the pulse, back to the square, and you'll get very traditional sounding pulse width modulation. But if you shuffle a table, then you're going to get something that's extremely unique, because you're not necessarily doing it in a smooth manner. Now, it will sound very smooth, but as you go, you're morphing from very, very different pulse shapes back and forth. The bottom two diagrams, not a very good illustration, but what it also allows you to do is to, when you're using the geometric shapes, is to alter the zero crossing point in the center. So we can slide that little circle to the left or to the right, and we can create very non-symmetrical wave shapes. Again, this is far from a deep dive because we just won't have time. The next illustration shows the basic concept of what's called a saw pulse. So we have half of a negative section of a pulse wave followed by the saw wave. And the saw wave will always go from kind of -1 up to 1. If you go to a saw pulse 2, you now have 2 pulse waves that are integrating with the saw waves, but you notice the saw wave maintains its shape. And there's also pulse width modulation available for that. So as you change the size of the pulse waves, the sine waves the saw wave automatically changes its segment length to adapt. So I'm going to go back and stop the sharing of that for now. Okay, so I think actually I'll pull up a brief audio example, and it's laid out there's basically 4 very, very short examples. And just to point out really quick, there's absolutely nothing used on this except reverb in the first example. The second example will have one of the effects that's incorporated into the synth, which is a reverse delay reverb effect. So there's no filters. Basically, this is just like straight out of the wavetable. So let me see if I can pull this up for you. And first, let me make sure that you can hear this.
Yep, it's there.
Okay.
What's the app we're looking at here?
It's an Android app called Wave Editor.
Okay.
Yeah, it's quite cool. Has some nice little spectral views. That example, just for anyone who might be curious, that's an example of a noodle that does sort of a split wave algorithm. So it basically takes a single waveform and it splits it up into separate tables. So that last piece was Fox Wave.
Hmm.
And that little bit was an example of still a work in progress, which is a sort of stereo sequencer concept, which I'll deal with very briefly in a couple of minutes. And I think that's pretty good for me for now. I think I'll turn it over to Jeanette.
Okay, so as you can see, the concept of wavetable generation using all these different algorithms alone can yield quite a lot of timbres and sound colors. But we also identified a few other utility modules in time that we thought might be really nice to have. So I mentioned oscillators. So for example, the oscillators that we have, they offer FM, PM, so phase modulation, 3 types of pulse width modulation, hard sync, windowing control, different quality playback options. We already have quantizers like pitch quantizers, linear value quantizers, ratio quantizers, modulators, which is currently only LFOs, envelopes definitely to come. Then there are things that we like to call post-oscillator or post-processing effects like wave folder and decimation, bit crusher type of things, different filters like multi-model sort of state variable filter, modal adder filter, utility filters like DJ filtering, so your average low pass, high pass combination, EQing stuff, all wrapped up sort of into quite usable opcodes a bit more in just a second. We do have a few effects already, which include modulation type effects, delay, reverb. You already heard the reverse delay there. Utility effects or utility modules, which is mostly at the time wave exporting and saving. So to export your creations and load them into other pieces of software or reload them into Csound. And there's definitely been work going on sequences and arpeggiators, things sort of striding that line. And I guess to show a bit more of that in interaction, it might be a good time to show another short demo. It's just under a minute. Scott, if I could ask you for that. Hello.
Yes, he's bringing it up, Jeanette.
Oh, sorry, I had my mic muted there. It's coming.
Okay.
All right.
Okay, and that was all pure Csound, no MIDI driving this time. Though, well, there's still a few things missing there. So the basic guiding principles that we identified or that we want for this project is sort of seamless integration, both with the OND opcodes and vanilla Csound. So everything we do, there's no magic. It's straight audio, K-rate, I-rate signals, the wave tables, they're F tables based on the FT morph opcode. At any point, you can decide whether to use something of the OND, use one of our wavetable creation algorithms, go into your own wave morphing or scanning. Yeah, sorry.
Yeah, I have two questions.
Yes.
Where can I see the code for the toolkit, and where can I see the code for the piece I just heard, or one of the pieces we just heard?
Yeah. Yeah.
The code, as I say, is yet unreleased. I'll come to that, and we could possibly see if yeah, we can share some code in a bit. So yeah, that's seamless integration. Another thing, of course, is to generate robust and usable code. So we have parameter safety, i.e. limiting parameter values, rounding them where necessary, using control flow if statements to make sure that when parameters hit the underlying Csound opcodes, that there's no undefined behavior or no crash situation where that is possible. I mean, it's not possible everywhere. We have some kind of error handling in the code, printing out error messages, trying to go back to safety faults so that even when something happens during a performance, the performance won't crash. It just won't be as pretty as you liked it, but at least it will continue. Again, there's consistency, of course, amongst the opcodes, but also consistency with Csound opcodes. So when you have something like one of our oscillators, it looks very much like oscill in Csound, only with added parameters.
That's
and
wise.
Where possible, we also try to provide very resource efficiency options. Not possible everywhere, but where we can, we try to do that because there are, excuse me, a lot of people nowadays working on smart devices, smartphones, tablets, but also single board computers like Raspberry Pis and bare metal systems. So that becomes a big issue there. The other thing, of course, is ease of use. So we try to be newbie friendly, try to offer good value for money with even minimal parameter amounts. So that you can use just a few parameters, get some good sound going. But then if you want to, you can dive into other optional parameters for the expert values and the deep dive. And we try to separate that so that you can really get going with just a little and experiment. And that also ties into another very important factor, I think, with the system that is now really growing and growing much beyond what we expected, is good documentation and good examples. So every opcode that we have is well documented. We're working on a browsable manual with categories and alphabetic listings. Every opcode has at least a very short, to the point technical example. But of course, we're also looking in the end at musical application and the musical context. So how can the opcodes be used when you're really making music? And also that should go into the examples. Having musical examples to entice people. And well, that is something that was from the start very important to Scott too. So at that point, I would like to hand over to him one last time. Scott.
Okay. Well, that sounded great too. Your piece is wonderful. So back to some of the wavetable creation process. It was quite a great learning experience. So some of the issues that we encountered during the development process was one, dealing with aliasing, because when you're using things to create hard geometric shapes like the pulse shapes, etc., you can end up with a certain amount of digital aliasing. So to get around that, part of the play UDOs that Jeanette has developed allow interpolation as well as cubic interpolation, which is largely effective to eliminate most of the aliasing. But that sort of led to a second area, which was developing a system of band limiting the waveforms. Some of the waveforms that are created, for example, via noise, which was largely done with the Gen 21 tables. I think Dr. B was sort of involved with those. You could, for example, say, okay, I want a wavetable that has 64 single cycle waves, but I want you to randomly create them anywhere between 4 points or 16 points. So you'd have this different limit of points, which again can be interpolated with slopes, etc. So one of the ways we ended up doing the band limiting was we had to figure out a way to scale the individual single cycle waveforms, because when you're using noise, you're going to get random amplitude values. And of course, you're going to end up with one table that has maybe 8 points and one table that has 17 and one that has 28, etc. So we also had to be able to scale the length of the tables, because when you're morphing, they all have to be the same size. For example, 1024 or 2048 are pretty standard wave.
Resampling.
Yeah. So in regards to that, it also became apparent that you could, as you're using something like Gen 30 to band limit the waveforms, you can choose the percentage of the waves in the table that you want band limited and which ones you don't. And you can also randomize the amount of partials that will be created from that waveform. So it could take the larger wave shape and turn it into 3 partials or 60 partials. So you get very soft downs and you get very aggressive timbres as well. And they're all sort of mixed throughout the wavetable, which creates very complex and interesting sounding wavetables. The other issue that came up was dealing with inharmonic wavetables, because with inharmonics, you often end up with single cycle waveforms that do not have 0 crossing points at each end. So that involved creating a windowing process so that as you create each single cycle wave, they're automatically windowed. And to that end, we've have some flexibility, which allows using sort of a generic routine like Gen 20, for example, and the user can define which particular type of window shape they want to use. Hanning, von Ham, sync is very good. But I found a lot of those were really intrusive, which sort of led to the development of creating some unique approaches to doing that. So can you see the screen okay?
Yeah.
Okay. So on the top, you can see a very standard shape of windowing. Now, if you try to imagine that windowing the amplitude of a sine wave, you can see how invasive that would be. So using other gen routines, we were able to come up with window shapes like you see in the bottom, which is a much, much wider, flatter window shape, much more efficient and far less invasive. However, on the flip side of that, if we look at the next picture, you can see that on the top, we have now a different shaped sync window, and we have a quite a different shaped custom. And again, these are all extremely flexible. This is sort of the deep dive part of that, which is very radical shape. Now, again, try to imagine those implemented over top of something like a sine wave. And what you get is really extensive ability to wave shape each of the single cycle waveforms. And it's not fixed. In other words, you can randomize every single one of the window shapes for every single one of the tables created in the wavetable. So for people who really, really want to deep dive in there, there's a lot of flexibility. I'd have a couple of other things, but at this point, I think, yeah, a quick mention of some of the, again, this is part of where we really still have to work on developing the code, but because it's very modular based, it can be constantly upgraded and improved, and which also allows, as Jeanette mentioned, the user to use templates and that to create all of their own modules. The sequencer that I used on one of the earlier pieces is based on a Roland M185, M100, and the IntelliGel Metropolis, and has a bunch of different modes like forward wrap, reverse wrap, forward ping pong, reverse ping pong. It has random walk. So basically it accepts an array and it will always step up to the next node or back. It can be fully randomized, variable gate length, number of steps included. So let's say you have an array that inputs a scale. So if you give it 11 steps, as it walks through, it's going to play sort of the notes like 1, 2, 3, 4, 5, 6, 7, 8, wraps around to 1, 1, 2, 3. Once you hit 11, it goes back to 1 and resets. Things like that. And the sequencers, at least the ones that I'm sort of currently working on, will work at I rate. So the advantage there is that it just creates the tables. From that point on, you just run everything, and there's very, very limited resource use, but hopefully
So
evolve
question
into.
about that.
Certainly.
Sorry to interrupt, but you had me at IntelliGel Metropolis. Is this part of the project? This, like, is it wrapped up with the wavetable project, or is this sequencer you're working on standalone?
No, it's all included in the project.
Okay.
But it
Yeah,
can work standalone. That, I mean, is the point that every of the modules within the project, you can use them all together, or you can just pick and choose, use just one, use all of them but one.
Right. Well, the reason I asked you is you had mentioned a focus on having the wavetable project be usable within Csound standalone, no magic, etc. And so it seemed to me that this might have been completely separate, which is cool. But like, I am eager to get my hands on the sequencer in particular. The wavetables are really cool sounding as well. Don't get me wrong.
Yeah, I would love to play with that stuff. I can't wait to see it.
There's a quick image of
Okay,
from the
yeah.
module, so you can see you've got your sliders at the bottom for the notes that are in red, and then you above it you have your gate lengths. You have how many repetitions, how many steps go through it. The scales will not be included at the bottom. You see there's a root and chromatic, because that will always be up to the user.
Sure.
To just input via array.
Sure. Yeah. Okay. I didn't mean to sidetrack too much. I just wanted to see if this was a side project that just happened to get intertwined, or if it was part of the same project. So
no, any sequencers we developed, Jeanette's developed a really wonderful arpeggiator. We're trying to basically reproduce a full hardware synth in Csound, but again, you can use it, as Jeanette mentioned, you can use it as a complete synthesizer package, or you can just incorporate any single element from the entire synthesizer into your own project.
I think that's a very good approach.
Yeah.
Yeah, I agree. And I agree with Richard as well about I'd love to see this in Cabbage too.
Yeah. Cabbage to provide UIs. Yeah.
Scott?
Sorry, Jeanette?
should we wrap up or
Yeah, I'm
do you
pretty
have...
much done.
Okay, then
Yeah.
I would just like to give you sort of the state of the art where we are at the moment. So all the existing code, as I stated, works, but there are a few things sort of to complete before we felt sort of comfortable with releasing it, like completing a few of the collections, adding a bit more in the quantizer, filters, and FX section. Definitely work on the sequencing tools and have some player interaction, as in also wrap up some of Csound's MIDI functionalities into very easy to use, possibly slightly dumbed down, but fun MIDI opcodes too. And of course, the documentation I mentioned, we need a fully browsable manual. We need more tutorials. And when it comes to tutorials, we also are considering a few sort of working templates, like create basic Csound template for creating and converting a wavetable, a synthesizer voice. And these, of course, would and could also go with a tutorial explaining how it works, where you could click in with just native Csound basic stuff, where you could say, well, your oscillator is fine, but honestly, bugger that, I'm going to use oscill. Yeah, fine. And I think that should be explained and should be very apparent, very sort of obvious. So I'm sorry that we took up much longer than we expected to. Thank you all for your attention. And I guess if you have some very salient points, of course, we're open. Otherwise, of course, we are always on the mailing list, being available by private email. Thank you. And thank you, Scott.
Will this eventually be available through GitHub?
Something like, yes. Yeah.
Something like that. Okay, great.
I'm waiting.
Excellent.
The bass sound that on that second example, Jeanette, that was really really warm and fat. What was that? What was going on there?
It was basically just all components from the wavetable system, and as you can see, we complement each other well. Scott and I, being Scott is so much more into the algorithmic approach, both in music and sound creation. I'm much more a control freak coming from MIDI synthesizers, so I used only 2 wavetables in that whole piece, and the bass was one of those wavetables. Going through one of the filters that we have, the mode ladder emulation, using one of the models that is available there. And yep, some EQing. That was basically it. So I guess you could do something similar with just a sawtooth and using one of the Csound mode ladder filters. What we did with our filter implementation is just sort of wrap up different models and try to give you all the same value scaling, like Q is always between 0 and 1, trying to sort of volume compensate for different effects, because some filters are a bit, shall we say, temperamental.
Mm-hmm.
So yeah, that's basically what we did there. Just try to tame the temperamental stuff and then put it all into a very unified value range.
It seems also a question for Scott. Thank you, Jeanette. The stuff that you were doing, Scott, reminded me, rightly or wrongly, of some of the Gendi stuff that Xenakis did. And I know there are Gendi opcodes now in Csound from Super Collider, I think it was. But there seems to be kind of a connection there between some of the stuff you were doing. Maybe it was a little more tonal sounding on your end, but like it kind of seemed like there was a crossover towards granular synthesis and some of those like really fine-grained, like micro-level algorithmic waveform changes that Xenakis was into. Xenakis.
Yeah, this is a result of using the inharmonic waveforms.
Mm-hmm.
And they inherently create noise, but what's really cool about that is that it creates very band limited type of noise. And so you would hear sort of noise come in and out and creep back, and very much sort of a filtering and a very, very natural filtering effect as you morph through them. So I think to a certain extent, it is similar to the Gendy approach, especially when the inharmonic partials are created as a result of using noise points that are connected with slopes, like I was mentioning, like a transeg envelope. So you can have logarithmic, exponential slopes between the points of the waves. So as it gets interpolated, you do get some of those Gendy sounds. A quick note on that too, I can post the link, or I can do it on listserv and Discord and stuff later. If you check out my SoundCloud page, there's several sort of droney wavetable sounds, and there's a couple that will come out that you get a very, very Gendy sound, very machine-like, like industrial timbres, quite different than anything you heard today.
Right. It seems also the fact that it's a wavetable and you're morphing it also reminds me of scan synthesis, which I think is more based on the individual like mileposts in the waveform being kind of dynamically moving while the wave is being scanned. But obviously you're doing something. It's a different approach, but they're both wavetable based, and they're both about dynamic change. But maybe
yeah, for sure. And as I think some of the art pieces I did and Jeanette's piece certainly show too the flexibility of the wavetables, because you can morph through them, you can step through them, you can randomly step through them. So there's no fixed approach, right? It's just completely up to your own compositional needs.
You can even make wave cubes, or take it up yourself and develop your own system of going through them. Because, it's sort of basic functionality. Just grab it, write your own code, or take something that you have lying around.
It seems to me that it's very good that the two of you working together on this, coming at it from different approaches, you cover a lot of territory that way, and also it protects against getting too narrowly into one particular perspective, which is great, because obviously you want this to be a very useful set of utilities, and I can't wait to play with them.
Can we pause here for a second? I'd like to ask Stefan, are you still there?
Yes, I am here, yeah.
Do you want to maybe take a stab at showing something, or?
Well, if you are interested, I of course could show you something. I'm sorry. Yeah.
So we're about an hour and 3/4 into this meeting, and I don't think we're quite done with the previous presentation. So I don't know how much you have to show us. Do you have an idea?
I think I'm just thinking, because I've now been listening to the presentation of micro Csound, and I'm at the moment working on a piece. The work in progress title is micro rack, kind of rack time. And I have just a few bars, no, not a few, about 1 minute, 35 seconds, something like this.
Okay.
And maybe this could be interesting. I did not use micro Csound because I didn't know of the existence of this.
Okay, fine. All I'm getting at here, what I'm surmising is that we can proceed for a few more minutes with the previous presentation, and there will still be enough time for you to show us something.
Of course.
Okay,
Of course.
so let's go back and let these people wrap up, and then we'll.
Yeah.
Well, of course, we've already, I think, taken more than enough time, and I guess we would really be happy enough to continue any kind of other discussions on the list by private email, on Discord. And
I had one question. If you wouldn't mind, could we revisit one of the examples? After you played it, Scott mentioned that it was generated from Fox.wave. And I thought I would recognize that no matter how it was mangled at this point. So I was a little surprised. And I'd like to hear that again with Fox.wave in mind this time.
Sure, I can pull that really quick.
Excellent. Thank you. That is fantastic. Thank you.
Okay. Something mumbling in there somewhere.
Yeah, I can get a little bit of that droney voice, but it's fantastic. I can't place it, and that really surprised me.
Well, it's because the wave is imported and then it's split into pieces. For example, I think I used 2048 for the table sizes. So each table is only 2048 samples from the wave. And then
Right.
they're windowed to make sure that there's no clicks occurring between the waves. So, you know, when you're taking such a short wave and you're cycling it at, 500 times a second,
Right.
it's just going to be completely inaudible. I doubt anybody picked it up, and I won't bother with it. I can post this later on my SoundCloud page or something. But in the first piece, if you listen really carefully, you can actually hear part of the vocals, because when you split it up that way, you can actually play the wavetable back at different frequencies, and you can literally duplicate the exact wave that you put in.
Isn't this sort of a reimagining of granular synth?
Absolutely. You literally took the words out of my mouth, Aaron. I was going to say absolutely. It's kind of a loose take on granular synthesis, including the windowing, right?
Yeah, because you have that you bring out the formants by basically the spectral nature of your source, but you're also looping it at a really, you're basically chunking it at a certain frequency, which gives you the bass tone that you're perceiving. But the spectral quality is really just up to the
and you can
morph.
You can morph from any point back and forward, just like you can with the granular opcodes.
Yeah.
Okay, so I suggest we move on to Stefan.
Excellent. Thank you guys for that presentation.
Yes,
Go on,
thank you.
Stefan.
Yes, I thank you all too, and thank you very much that you are listening to my words. I'm actually now working on a piece called Micro Rack. Maybe it will later have another title. My idea was to try to something different like Conlon Nancaro did. I guess you all know this guy.
Yeah. Oh, yeah.
But in my idea, I wanted also to use microtonality, which Nancaro, as far as I know, did not make use of it. That's my idea, and it's just a beginning, and I'm in doubt how to go on with this piece, and there's no effect, no reverberation, nothing like this, just the pure C sound, and it's something like a piano. I did not intend to make a real piano, but I wanted, I never get caught, but I wanted to make an instrument a bit like a piano. It's made of additive synthesis. With the kind help of, you all know him, but at the moment I forgot the name, Mr. Csound in Germany, Joachim Heinz.
Yeah.
Joachim helped me to build.
I knew that's what you meant.
Yeah. Okay, I just play the piece, and maybe we can have a short discussion if I should go on or not. I will share my computer audio. Yeah, so and I just play it from the console. Share, and let's start. All right.
All right.
That's all. That's a moment.
Okay,
That's cool.
I have a question.
Yeah, I like the arrangement. The arrangement was really interesting.
Is that an EDO you're using, Stefan?
So, sorry?
Is that an EDO scale that you are using?
Yeah. 41 notes per octave.
Cool.
Because you have these Pythagorean intervals and you have not so bad just intonated intervals. Maybe I could have done it with 53 EDO as well, but I'm not so much interested in those pure intervals. And of course it must become more complicated in rhythmic things.
Yeah, Nankara was always doing different streams of notes in different tempos and different meters.
Yeah, 7 against 4 and some actual runners, but this must become, it must go on. So I'm still working on it.
And I have a question about the sound.
Yeah, of course.
Did you try a sound with a more percussive attack?
A sound with a more percussive attack. Well, how could I reach its aim? That's the question. I think I'm not the best one in sound synthesis.
Okay, I will send you some. What's your? I think I have your email. You're on the.
Of course, I can send you my email and would be very interested in getting some advices.
Okay, do that.
Yeah.
I have a question too.
Yeah.
How do you drive the score at the moment? Do you write C-sound score, MIDI, or
No, I've written it in Python. It's pronounced Python, I think.
Yeah.
And if you like, I can show you something of it if you are interested.
Yeah.
It's a little bit like Aaron's micro C sound, but I've done all by myself. So I invented all the names for this music, and at the end I have a pure C sound score. But this C sound score is written by Python. That's a procedure.
Oh, okay.
But maybe a little bit too complicated. I don't know. I can show you the process. Down. So this is the first. I will show you the Csound score. Of course. Okay, it's included. So you have a lot of code, and this has been. I made these are macros.
Macros.
Yeah, macros. So I have to declare what is C6, G5, or ISO is A sharp a little bit lower. This is my invention for this pitch.
What I think, what I would like to know is,
yeah,
you didn't just write this out. You wrote a Python program that generated this.
Yeah, I do think something like this. I can show you the first.
Here we go.
So this is the baseline. There is well, this is an how to say another variable thing. I declared where it is. Oh, okay, it's declared in bibs. What it's in the file bibs. So can show you as well. Something like this. It's bus.
Okay, I get it. I see now.
So there you can see these. So and these are still the pitches. The rhythm is there's the rhythm, the durations. Okay. Okay, this is quite complicated because it's somewhere else in somewhere else files. I've declared everything. Here you see bibs dur pad. It's always the same pattern of durations, something like this.
Right.
Yeah. And I had a problem with what can I do if the duration, if there are rests between the attacks. So durations are is a rhythm, and if there are rests in between, I have this spans. I've called it spans. So mostly duration and span are the same, but sometimes the durations are a little bit longer if it is super legato, or a little bit shorter if it's a staccato, something like this.
So it looks like your rhythm, your data structures for declaring rhythm and your data structures for declaring pitch are separate.
Yeah, yes, pitch and rhythm. I can input both things at the same time, but at the end it will be separated. Okay. And sometimes, sometimes if the rhythm has the same pattern, I input the pitches separated by the rhythms, because the rhythm pattern is repeating.
Mm-hmm. Yeah, I did some Pio. Pio is a DSP package for Python, and I used tuples to represent pitches and rhythms and whatever, and then it unfolded the tuples into various sequences, which was nice. But I still think if you're going to extend this, it might be worth your while to re-implement what you did in micro Csound, and then you can continue, I think, a lot faster.
I thought so. As I saw you explaining micro Csound, I thought, well, you should get to know it. Me should get to know it.
Yeah, because I think it would be it's a pretty economical representation of all these things.
Yeah.
So each little token has all the info it needs to render the score.
It seems perfectly suited to it. Yeah.
Yeah.
Yeah. This is really a complicated process. Yes. And even especially if you make a mistake and you don't find it, it's a nightmare, really.
Yeah.
I believe that.
Yeah. But that's a good start. It's and then you can also play around with the timbres too by just altering the orchestra and
yeah.
Yeah, good stuff.
Yes, but well, it's a lot of work to do, and it's just for fun for me at the moment.
Yeah.
Oh.
Question for you, Michael. Since you were
Yes.
talking, this kind of overlaps with what Stefan is doing. For the Csound WASM, I only glanced at it, but is there a way to, I know JavaScript has strict security practices around files, unless you actually download them with a sub request or whatever, typically, unless you're on Node.
That's a very good question.
Yeah, but if you have samples that you want to load or sound fonts, right?
I don't load samples or sound fonts. I used to build a set of sound fonts into the WASM file.
Yeah, okay.
And that was hard to maintain, and I didn't use it, so it fell off. It could be
Plus,
put.
it's not customizable for new users then too.
No, however, you could do what the regular canonical build of Csound for WebAssembly does, which is to basically cut and paste from the hidden file system that WebAssembly uses into the user system clipboard. So I have that working to come out. In other words, you can perform a piece in my Cloud 5 system and it will be recorded as a sound file in the private file system that you normally never see. And then you can request it and download it, and you will have it in your own regular file system. So that works. So you could do something to go the other way. I've never tried to do that. It's a fairly...
In other words, slurping in an input file.
Yeah, that's right.
Yeah.
There's no other way than some kind of inter-process communication to do this at this point, because the security risks.
There's an interesting, so the guy who developed Pio, he has a thing called Radio Pio. And one of his things was, share files, and we'll share, like there's basically a web radio station for all these Pio things. And he's like, one of the rules is no sound files, right?
Yeah.
Although his own piece breaks that rule, but he goes around it by basically embedding a kind of zipped, like base 64 representation of a WAV file.
There's another thing to say here, which I think will become available in Csound 7.
Yeah.
I think in Csound 7 that an opcode that reads a file will be able to stream the same data from an internet URL.
Okay.
So you could have a local web server on your computer that was serving sound files, and then the regular Csound opcodes could simply load these sound files.
But also you could use a buffer, right? Like if you did want to do the same approach in like base 64 encode a wave as a buffer, there would be some way to read that in Csound and turn it into a wave, yes?
Yes, indeed, and I can tell you how to do it, but it's tedious. What you would do is you would encode the thing embedded in your piece. Your piece would be an HTML file.
Yeah.
And a big chunk of the HTML file, probably most of it, would be samples.
Be the wave, yeah.
And then your JavaScript code on that same web page would find these elements with the sounds, and it would use the Csound API to load up the wavetables.
Yeah.
So that would be done in JavaScript. That would work fine.
Yeah.
Not even that complicated to do. But I don't normally get samples, so I'm not going to do this myself. But I know
It's certainly not space efficient to
There's
encode.
Probably would be
I
better.
gotta tell you guys, you have no idea how much space there is. There's a lot of space on a modern,
Okay.
a modern personal computer. You can
Yeah.
forget about it. There's gigabytes. You've got the space.
I know.
But with the approach of using a wave file, I think with JavaScript still it's the best, especially if it's right there. A sub request to fetch it and somehow load it in the API would be better. Would be the best way with web.
Well, when the page loads, it can go ahead and just do all this stuff before it starts.
Yeah.
It should be very straightforward.
Even a moderate sized sound font, right? Even a moderate sized sound. even a modestly sized sound font would be reasonable to download. You know, like
Yeah,
a
but
small
you see,
sound
you
font
can't,
that had some key things in it.
right, but the Csound opcodes could not directly use the sound fonts in a web server. So they would have to be, you'd have to pull the data out of each table in the sound font and stuff it into a Csound wavetable in JavaScript. That's a
You
lot of
mean you
work.
don't have the sound font opcodes in WebAssembly?
They, I don't. I think maybe the
The
canonical.
other build?
Yeah, I think maybe it does.
Okay, so your build doesn't have them.
Actually, I'm not sure. Maybe it does have them. I'll find out. I'll get back to you on that.
Okay.
I've never used it, but it might be that if you get the sound font into your private web system, your private file system, you can just use the Csound opcodes. I'll check that out.
By the way, I think one amazing thing that Csound should pick up on is there's this new technology. I forget the name of the synth, but there's a guy that's using AI to kind of create FM patches that basically start to zero in through an iterative process on a sample. In other words, there's like a whole feedback loop where, like, if you give it a random sample, it does a few iterations and then finally figures out, here's an FM patch that produces that sample pretty closely.
That's very interesting. I think we're going to be seeing a lot more of that kind of thing.
Yeah. So in other words, you don't even have to have the sample. You just have basically the envelope shapes for the modulators that produce the sample.
Right.
Which I think is a fascinating development, and
I think that
something
might
that
have
actually
been
compresses the signal.
vital.
Go ahead.
I think that might have been vital. And Scott, I think we both looked at that video. Certainly, I can remember it from a subtractive synthesizer that used that particular technology to sort of import samples and try to emulate them through just the simple synth engine. And it wasn't even that complex. Okay, had the usual components like two oscillators, filters, FM,
Right.
reverb, but yeah.
Yeah,
I
and I'm
think
not
that-
sure if it's the plugin you're referring to, but there was also that plugin that we were looking at, Jeanette, remember, that was the AI plugin that will take any synth sound and use AI to break down extremely complex
Yeah.
timbres and basically reproduce them using only two oscillators and modulators. It's
Exactly.
phenomenal.
Yeah.
And it
Yeah,
created
yeah.
that tree. It creates a tree where it gives you like hundreds of variations on the sound.
Synth
And
plant.
synth
plant.
plant.
That's it. That's exactly what it was. Yeah, synth
The
plant.
latest version of synth plant. Yeah. Sorry.
Yeah. So it's like
Distraction here,
an
but-
evolutionary. It's like an AI-driven evolutionary system that basically uses the best approximation of a generation and then uses that to kind of explore the vast space of possible modulation, and then give you, and then eventually it arrives at something that pretty much reproduces the original input sound, which is fascinating.
With very, very little complexity in the end.
Exactly.
Like in terms of like very little processing with just a couple. Yeah. Anyways.
It'd be wonderful to see. It would be wonderful to see something like that doable in Csound, like, in other words, an analysis plugin that did that kind of thing. But then it's like, okay, here's your FM patch that does that. But I think that's a lot of dev work, clearly. But yeah. But maybe you can ask ChatGPT to write that plugin.
You can.
I want to do a
Ask the-
synth plant in Csound. Go.
Yeah, right.
Yeah.
Ask the AI to write an AI.
I think the eye is not big enough for that yet.
But I've been amazed, like I've been both amazed and disappointed by what ChatGPT is capable of. Like, in the same session, it's like, wow, that's amazing. You just gave me a way to extend my own code, and wow, you really don't understand this.
Well, that's the thing. AI doesn't understand anything.
Yeah.
It's
Nope.
just good at
I've had
processing
to correct
existing
it,
information.
and I would say, I think you're doing this, and it's like, oh, thank you for the correction. Here's the right. Sometimes you'll get it. But I've had sessions where I've convinced it that 3 equals 2 and stuff like that too, like ridiculous stuff. It's not good at math, ironically. So
Stephen Yee and some others were playing with that. They had temporarily had an AI on the Discord forum.
yeah,
And plus people had posted a few examples where they'd gone in and said, okay, create me, here's a timpani, create me a Csound patch. And it was just horrifically bad. So they're not there yet. Anyways, Michael, quick question before you, because I know you're going to probably want to wrap up pretty soon. So pretty simple yes or no here. Does the Android app support MIDI input? If I was to use a MIDI interface with the Android app, will it accept MIDI?
I think it might, but I can't tell you for sure because I never used that. I don't have a MIDI controller.
I can't think of any technical reason why not, as long as the
It's
the
a
opcodes
question
are in
of
the
the MIDI
build.
API, but
Yeah,
we looked at that the other night, and the only API for MIDI I found on Android was sort of the only MIDI driver was the Android specific.
Oh, wait a minute. I'll look at my code and it will tell me because I will have set it up. I would have had to write something. Hold on a second. It's
Okay.
Right here. Oh, for Android.
yeah.
We couldn't find anything specific, certainly not in the manual.
I was thinking about the WebAssembly.
Oh, right. Because I hadn't seen any of the standard drivers like Core Audio, Core MIDI, Port MIDI that would be supported by Csound. I don't know if any of those exist on Android, any sort of cross-platform MIDI input driver.
I think let's see. I'll tell you the answer in just a minute here. I just have to open the right directory.
hey Thorin,
Yeah.
question for you. You should present diving at some point. That's such a fascinatingly great piece.
Oh gosh.
And
I'll have to
like,
remember
not only
how I made
the
it.
music, but the timbres. And I know it was like it took a crazy long time to render back in the day, where it's like, okay, here's the source code. And I remember running it and it like broke my computer because it was like one of the more complex generation. I think it included some FM or something like that, but there was something that was like super, like you did some super inefficient but really rich instruments in that, which was kind of like cool.
It is great sounding.
Yeah,
It's beautiful.
Thanks. Yeah.
And how did you?
Okay.
And back your question back at you. How did you find the time to do that?
Well, that's the thing. That was sort of, before certain things in life take over,
Yeah,
jobs and families and stuff. And that's kind of why I was asking you, Aaron, because I know you have a day job.
I have a day job.
You have
and
a family
daughter and
to
a
worry
wife,
about, and yeah.
Well, to answer
that's what
that,
slows me
it's
down essentially.
Last night I was like working on. I got a presentation. So wife comes in at 10 p.m. Time for bed, and I'm like, it's not done.
Yeah.
Not done.
Yeah. Okay.
So
Yeah, I'm familiar with that.
so it's
So I looked at both.
I'm not saying everyone's always happy.
I looked at the WebAssembly code and the Csound for Android code. I don't see an obvious mention of MIDI input. But what I will do is run these things and print out the list of opcodes And if I see there's MIDI support in there, I'll let you all know on the Csound list.
Just
Sure.
a small note on what you guys were talking earlier about file input. Don't forget Csound's got that CS, what's it called? The CS file B tag? A
Oh, the
CSD tag?
tag in the OS in the CSD file.
Yeah.
Right.
You can, and it lets you basically put a 64 base encoded
You
text
could,
there
and then what would
blob, any
happen
kind of
during
blob.
in the
if during-
CSD.
What happens then? During performance, does it export those things to the file system? If
I've
it
never
does-
used it.
If it does, that solves the whole problem.
Hmm.
Because then you can just use the regular opcodes on those files.
Yeah. Well, this I guess is a question for the mailing list too, but
I'm gonna look at the manual because it
just
might,
for a hoot though, I'd like to be able to cheat in that way, like stuff a B64 encoded blob into the.
well, you can
And
do
remember, Csound ships with the utility as well.
Yes,
Yeah. But
The
it's like more
encoder,
about what's
CS.
available on the WASM build, you know, like and if it works
yeah.
with JavaScript's ecosystem.
well, all the file reading and writing opcodes are there in the WASM build, but they will only work on the hidden file system, the private file system.
Right.
But if Csound will write the encoded blobs back out into that file system, then of course all the Csound opcodes will just work with that. So I don't know how that actually is supposed to work.
So if the hidden file system has a sound font, are you saying it would just know what to do and load it if I refer to it?
If the opcodes are built into the binary, yes.
Okay.
So I have to check that,
Okay.
and also what happens with these blobs.
Isn't there equivalent to Csound-Z to see what the
And of course, I've used Csound.z in both Android and WebAssembly. Sure, it works fine.
Okay. How do you access? But that's meta outside of the normal.
No, it's not. You
Or
just
is that available in the JavaScript API through a call?
No, you just put it in your Csound options.
Oh,
Z.
okay. -Z. Yeah.
Yeah,
Okay.
-Z.
And the console will show it. Yeah.
And
Right.
the console will show it. -Z1.
Got
Yeah.
it.
Yeah.
Beautiful. Yeah, it's exciting, I think. And it's pretty amazing what a modern browser is capable of doing, you know? But
Yeah, who needs operating systems?
That is the operating system.
That's it.
I do.
I do too. But
Well, yeah.
You need
The
one to
bloody
run your
browsers.
browser.
The bloody browsers aren't very accessible, unfortunately, when it comes to that.
True.
And
Oh,
that
listen,
can
yeah.
be a bit of a problem. It changes, of course, slowly, but of course, then there are not too many browsers who support the full might of all this web technology. And I mean, these days, I think it's still recommended that it's best to use something like Chrome. And
Right.
yeah,
Firefox and Chrome, and they will probably work fine. I've used them both. So I'm reading the base 64 file section of the Csound manual. Yes, the file will be extracted to the current directory and deleted at end of performance. If there's an
Nice.
already existing file with the same name, it is not overwritten, but an error will occur. You can use any old file, MIDI files, and samples.
wow. Okay. There you go.
And you can also include unencoded files. But
wow.
that's not going to work, because then you're referring to some file that's not in the private file system, so that wouldn't work.
Yeah.
But the encoded data will be written out and will be available. So that should work. You should be able to base
Jeanette,
64.
would the micro Csound online tool, would that be something that do you use a modern browser, or are you using something like Lynx or something to connect to the web?
You mean me? I mostly use Lynx because I'm working on Linux system, command line only, because it's very, very convenient. when I'm not using Linux, I'm using macOS, but there I'm using Safari because it has the best accessibility support, of course, being Apple made. Yeah, well, I mean, they have
Yeah,
their
I
own
mean, I definitely
restrictions,
would.
and
If you were interested in using this tool, I would definitely want to gear it towards accessibility too. And so, you know, if you want to give me feedback on that, I'm happy to do that. Like I would assume that, I could start by just checking,
I would be the
the
wrong
linter.
person there,
Yeah,
because I don't use the Mac that often. I only use it if I have to, and it's just a notebook, and I have
yeah,
no
yeah.
audio interface connected. I could
Which
still
links do
look
you use,
at.
INK or the YNX one?
I use both of them on Linux, but they none of them support JavaScript, so it would just be Mac.
Yeah, yeah.
I could certainly look at the website and see how well that works. Yeah, certainly. You could just hit me up privately. We could check that out.
Yeah.
Certainly. Yeah, cool.
It'd be interesting to see a browser that was text-based that still I wish those, you know, because I sometimes use those command line browsers too, sometimes to, you know, read an article that would otherwise be blocked by JavaScript or something. So, but it would be nice to see a browser like that that would still support JavaScript in some way, especially if the JavaScript app in question wasn't so graphic
You could just
centric and
also
more
use
about text.
NPM.
Sorry?
You
Oh,
could
use
also-
NPM.
Yeah.
Yeah.
Okay, I just now looked at the opcodes in my WebAssembly build of Csound, and all the SF opcodes are there. So if I can encode a sound font into my CSD and serve and run the CSD using my WebAssembly build of Csound and hear the samples, I will let you know. So the parts are there. Whether it all actually works, I don't know yet.
Yeah. But then the other thing is you don't, you know, does one want the JavaScript source code to be like, you know, 200,000 lines of encode, you know, embedded?
It wouldn't be the JavaScript source code. It would be the CSD that's embedded in your web page.
Yeah, yeah.
And yes, it would have to be that big. And so what? So
Yeah,
what?
no, that's fine. But it would,
I mean, the
you're saying it would
JavaScript
still
can be minified, you know.
No.
But it could
It's
be a
just, you know, you
sub-request,
guys are
right?
worried
Like
about a problem that doesn't exist. There's a lot of room.
I'm not worried about the room. I'm just worried about the source code being littered with the B64, but you could sub-request that.
All you do is you put folding points into your code and you just hide it.
Yeah.
It will slow down the editor, but it will work.
True.
Yeah.
Well,
Good session today. Lots of stuff.
Yes.
lots of good stuff. Yeah.
Lots of good stuff.
A quick one, Michael. I know sometimes it's easy for us to lose track of what we've done before, but some of your earlier web sound pieces did use sound fonts.
Yes, because as two things happened. I used to build sound fonts into the app, into the Wasm Csound, which I don't do anymore. And I also had my own version of the sound font opcodes, which I'm not supporting anymore. But they do the same thing as the canonical opcodes, which do exist in my Csound for Wasm. So those pieces wouldn't run now, but they could be redone so that they would run. But also, I do HTML browser-based pieces, not only for web servers, but also for nw.js. So that's how people make applications for the desktop using browser technology. So it kind of hides a local web server inside the application, but it doesn't have any of these sandbox limitations, and it can read and write the regular file system. And I use all kinds of samples and whatnot when I make pieces like that. VST plugins, you name it. So it looks, when I run one of these pieces, it looks like I'm running one of my web-based pieces. It's actually, it's using the same HTML and the same JavaScript and the same Csound API, but it's able to use binary plugins and samples and stuff like that on the local file system. That's probably confusing.
Certainly very clever.
One have to run now, but thanks everyone. It was fun. And
Yes.
Yeah. I think I'll wind it up, and thank you all.
Yes, thank you.
And
Thanks
Thank
for
you.
hosting and thanks for the
Thank you.
presentations, everyone.
Yeah, a lot of good stuff.
Yeah, and thanks for recording that, Michael. There have been several requests for that as well as on the Discord forum, so it will be really nice.
I don't know what I can do with the recording. It's going to be huge, and I may not have room to host it anywhere, but I'll see.
Well, you can contact me about that.
Room, and we
Okay.
have plenty of room everywhere.
Well, some room you have to. Some
Eat
room
your
you have
words,
to pay
Michael.
for. Room in
Depends
the
on context.
There's plenty of room on my computer. I didn't have to think about it. I didn't have to worry about how big it was on my computer. But to get it to you, I have to go through a dinky pipe. Yeah.
All right, you two can fight to the death. I'm off.
All right.
Bye, everyone.
Bye-bye,
Bye-bye.
Michael. Thank you for
Bye-bye.
hosting.
Good to see you all. Thanks, Michael. Thanks,
Bye-bye.
everyone.
Thank you, Mike.
Bye.
Yes. Goodbye.
Bye.
Bye.
Take care.
Bye, everyone. Thanks.